This is problem 11 of the 2023 AIME 1, and the problem reads, find the number of subsets of 1, 2, 3, 10 that contain exactly one pair of consecutive integers. Examples of such subsets are 1, 2, 5, and 1, 3, 6, 7, 10. Okay, so when we look at a problem like this, we always have to ask ourselves, what's so important about the fact that we have 10 elements in this set? And if you think to yourself, what's so important about 10? The answer is there's nothing special about 10. I could have easily asked you this question about 1 to 5, 1 to 13. I could ask you 1 to 32 and have you solve that for me. And when you look at a problem that has a number that doesn't really matter, you kind of want to generalize to a more specific problem. Find the number of subsets of 1, 2, 3, n. 1, 2, 3, n, for which that it contain exactly one pair of consecutive integers. So why don't we start out with small cases? The set 1. How many subsets of the set 1 contain exactly one pair of consecutive integers? The answer is, well, 0. Just because, well, how do you find two consecutive integers in the set 1? You don't, because there aren't. If I ask you the same question with the set 1, 2, your answer would be 1 because only the subset 1, 2 contains exactly one pair of consecutive integers. But when you get to higher numbers, you start getting it becomes a little harder to count. Like, for example, 1, 2, 3, how many are there? And the answer is going to be 2 because the subset 1, 2 and the subset 2, 3. That's still fairly simple, but by the time you get up to 1, 2, 3, 4, 5, 6, for example, how are we going to make sure exactly one pair, no more, no less, of consecutive integers are in your subset? So we're going to need to be a little smart about this and maybe solve another version of a slightly easier problem. And this is going to turn out to be very useful, namely, how many subsets of 1, 2, 3, 4, 5, 6, 7, all the way up to n contain no pairs? So let me write no pairs here. Um, and when you look at the set 1, how many subsets of 1 contain no pairs of consecutive integers? The answer is 2, namely 1 and then the null set containing nothing. Both of these don't have a pair of consecutive integers. And what about for the set 1, 2? How many of them have no pairs of consecutive integers? The answer is going to be 3 because it's going to be the set 1, the set 2. Whoops, that's not a 2, the set 2, and the null set. And if you were to repeat the process for 1, 2, 3, I'll let you work it out yourself. You're going to get 5. 1, 3, 1, 2, 3, and null. And you can go on and on and on. And for notation purposes, why don't we denote this something like A1, and this is going to be A2, and this is going to be A3, and let's denote this B1, B2, and B3. And what we ultimately want to find is A10. A10 equals what? And this is where we really get into the meat and potatoes of this problem. Namely, how do we find A of n? Well, you can think about it this way. A of n is the number of ways you can choose a subset of 1, 2, 3, and I'll say n minus 2, n minus 1, n. How many ways can you choose a subset that contains exactly one pair of consecutive integers? And there are a bunch of different ways we could come up with a subset, but I'm going to split the subsets into 3 main groups. Group 1 contains n and n minus 1. Group 2 contains n but not n minus 1. Group 3 has not n. And we count the number of subsets in each group, and we claim that all of these subsets will comprise the set of subsets that we are looking for. Namely, there is no subset that we include in our account that's not in one of these three cases. And you can think about that if you want. But anyway, how many subsets that have n and n minus 1 are we going to count? Well, if it has n and n minus 1, the set definitely has that pair of consecutive integers, which means that if we're looking at exactly one pair of consecutive integers, it cannot have any other pairs of consecutive integers. So we have n, n minus 1, and some other stuff. And the question becomes, how many ways are there to choose this other stuff? Well, first of all, n minus 2 cannot be in the subset because n minus 2 and n minus 1 are consecutive. And so every other element in this stuff is going to be between 1 and n minus 3. But no two integers in this stuff are consecutive, so, because otherwise they'd be a pair of consecutive integers and you would not have exactly 1. And therefore, how many ways are there to choose this stuff? I claim it's bn minus 3, the number of ways to choose several integers from 1 to n minus 3 such that no two are consecutive. Okay, so that's group 1. Group 2 has n but not n minus 1. And in this case, we have something like, well, if it has n, it doesn't have n minus 1. All the other elements in this new stuff are going to be in this set 1 to n minus 2. But how many pairs of consecutive integers do we want from 1 to n minus 2? Well, we want exactly one pair, because n is not going to be part of a pair of consecutive integers, and we want exactly 1. And therefore, the question becomes, how many ways are there to choose subsets of this guy to go along with this n such that there's exactly one pair of consecutive integers? And you notice that's exactly an minus 2. Number of ways to choose subsets from 1 to n minus 2 such that they're exactly one pair of consecutive integers. Finally, our third case is that n is not in the set. So you can sort of exclude n in this case, and you look at 1 to n minus 1. And if n is not in your subset, which just contains some stuff, well, all of your subsets are going to contain elements just from 1 to n minus 1, and you're going to need to have exactly one pair of consecutive integers, and you'll notice that's equal to an minus 1. So what do we see? We have that an is just the sum of everything in these three groups, which is an minus 1 plus an minus 2 plus bn minus 3. You see this formula, this is our recursive formula that we can use to solve this problem. So one last thing we have to do is we have to figure out what are the A's and what are the B's. And I claim that we can find a recursive argument for B of n as well. Namely, B of n is equal to B of n minus 1 plus B of n minus 2. And if you didn't know this already, you could pretty easily derive it using some of the same logic. If you have a set 1, 2, dot, 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 n, how many ways are there to choose a subset that contains no pairs of consecutive integers? Well, either n is in the set or n is not in the set. The number of ways to choose a subset that contains n is, well, if n is in, then n minus 1 cannot be in, and you're just choosing from 1 to n minus 2 to fill the rest of the subset, in which case you have to choose a subset from 1 to n minus 2 that does not contain any pairs of consecutive integers. This is bn minus 2. Ways to choose this one. And if n is not in the set, then you're basically asking the same question for 1 to n minus 1, in which case you're getting bn minus 1 for the number of these subsets. Okay, so that essentially proves our claim that bn is equal to bn minus 1 plus bn minus 2. Finally, all that's really left to do is to compute some values of a and b until you get up to 10. A10, that is. So let me make a little table that we can use to keep track. And we're going to put N, A, and B. So when N is 1, we know that A of 1 is 0, B of 1 is 2. When N is 2, A of 2 is 1, and B of 2 is 3. And you can sort of fill out the table this way: 3, 4, 5, 6, running out of room. So A of 3 is 2, B of 3 is 5. Now, B of 4 is 8, B of 5 is 13, B of 6 is 21. We can find A4 is equal to A3 plus A2 plus B1, which is equal to 5. A5 is equal to 5 plus 2 plus 3, which is 10. A6 is equal to 10 plus 5 plus 5, which is 20. And let me extend the table out right here. When N is equal to 7, 8, 9, 10. We see that B of 7 is 34, B of 8 is 55, B of 9 is 89, B of 10 is 144. A of 7 is A of 6 plus A of 5 plus B of 4, which is 38. A of 8 is 38 plus 20 plus 13, which is 71. A of 9 is 71 plus 38 plus 21, and that's equal to 130. And finally, 130 plus 71 plus 34 gives us our final answer of A10 is equal to 235. That is our answer, and that means we are done. So thanks for watching, and I will see you next time.